Okay, Pulleys example 2, and this is from January 06, so an exam question. Okay, so you've got a diagram shows body A of mass 9 kilograms, so add that to my diagram as well, connected by a light and extensible string, passing over a smooth light pulley to body B of mass 5. Body A is on a rough horizontal table, body B is hanging freely, the coefficient of friction is just mu. If the system is in equilibrium, show that mu is greater than or equal to 5 over 9. Okay, so first thing to do then, let's put all our bits onto our diagram. So I've got my diagram here, got 9G and 5G as the weights. You've got tension and tension there. It's friction here like last time because it's a rough table, and reaction. Okay, now because you want to show that mu is greater than or equal to 5 over 9. There's a few clues in that. First off, it's not moving because it's in equilibrium, so it's balanced. So I'm going to use the less than or equal to symbol, basically this, but it rearranges, but the less than or equal to symbol in friction. Okay, and because it's such a whole number, I'm going to keep G in my answer as I'm going along, so I can get to this perfect answer at the end. Okay, so I'm going to use this formula this time. Friction is less than or equal to mu R. Sorry, the sun's just come out and it's gone really bad. Okay, that's a bit better. So friction is less than or equal to mu times R. So first thing I'll do is I'll find R. So to find R, I'm going to do forces up equal forces down. So back to the diagram for this. So forces up is R equals 9G. I'm actually going to leave it as 9G because I've got a 9 in my answer there, so I'm thinking maybe the G's will cancel out later on. Okay, if I put this back into friction, I now got friction is less than or equal to mu times 9G. I have to pause it to the same. Okay, so we've got that part there. Now we can have a look at the 2A and B and try and come up with some simultaneous equations. Okay, to put in, basically you want to put something in for friction so you can rearrange and get mu. So for A, now remember it's in equilibrium. So because it's in equilibrium, it's balanced this time. So if it's balanced, it's not going to use F equals ma. We're going to use forces right equal forces left. And then the same for B, we'll use forces up equal forces down. So for A, if we go back to our diagram, right equals left, T equals friction. For B, up equals down, T equals 5G. Because it's in equilibrium, it's not moving. Okay, so we end up with T equals friction for that one, that's our first equation. And T equals 5G for the second one. The second equation there. Okay, now this one you can solve slightly differently because they're both T equals. You can put them equal to each other, okay, or basically substitute this into this one. So you end up with friction equals 5G because they're both T equals, so put them equal to each other. So now because I got friction is 5G, why don't I put that back into this? So I end up with 5G is less than or equal to mu times 9G. Hopefully most of us can see now we're almost at the answer. Take this over and divide. Cancel your G. And look, I've got my answer. If I move it the other way around, I've shown that mu is greater than or equal to 5 over 9. Cancel the G's, swapped it around. Okay.